Good afternoon, everyone, and welcome to the NX Mold Tool and Die webinar. This is the first webinar in the Digital Machine Shop series we'll be doing this year. Presenting this webinar is Jason West. He is one of our technical experts here at CamLogic. He's been with the company for around 8 years in many different capacities. He's very technically inclined, and we're thankful to have him here. Thank you all for coming, and please save your questions to the end, and we will address them.
So my name is Jason West. I'm not sure how much everybody heard of this, so I'm just going to run through this again here real quick. I have 16 years of mechanical engineering experience with customers. I was with 2 different companies over those 16 years. Focused a lot on the manufacturing, heavy sheet metal, as well as data management. Spent the last 12 years on the Siemens reseller side, so being able to help our customers maximize their investment with their Siemens products, Solid Edge, NX, and Team Center. Taking a look here at the innovation wheel. We take a holistic overview to engineering. So not only do we develop, so we offer Siemens Software, Markforged printers. We also have in-house manufacturing capabilities on the additive and the subtractive side. So we have over 30 printers on our additive side, and we have 3D router, milling, lathes on our subtractive side. The capture side, we help our customers with quality control. So we do scanning and prototyping services. And then on the Conceive, we also have an engineering team that can help offload some of your engineering needs. So we can come in and do design, do reverse engineering for you as well. Taking a look at the series we're going to start with today, which is our mold tooling. Taking a look at industrial molds. 41% approximately go to the automotive industry, 16% to the electronics, and around 14% go to appliance manufacturers. So tool makers are always facing issues with complexity, new products, globalization, increasing quality requirements. So today's manufacturers are under a lot of pressure, right? You guys are there, your customers are demanding, even expecting, higher quality, better accuracy, consistency. The pressure to deliver shorter lead times with a higher quality product, as well as reducing the cost, right? So it's always a struggle to balance out those and make sure that you're delivering a good quality product in a short amount of time, with the least amount of effort on your side to be able to get that product out. So today we're going to take a look at what we can do with inside of NX in the Mold Wizard and mold tooling processes that we have. So having the ability to share and interact early in the process. So I'll cover some of the what's new here towards the end of this presentation, but being able to collaborate with the stakeholders a lot earlier in the process. So having a tool, a cloud-based tool where you can get everybody on the same page, focus on, capturing and reusing as much tools and hardware as possible, and looking at how you can utilize additive manufacturing in some of your mold designs as well. So Siemens Software has been focusing on, helping tool manufacturers digitalize and develop their whole process. So not just focusing on one piece of the tool, but really coming up with a good, consistent workflow that's repeatable. Being able to transfer that data downstream, so sending it off to your manufacturing room to have the components built. Focus on getting purchasing involved with ordering parts, so having that bill of material up front of standard components that you're going to need to purchase, and just really focusing on bringing it all together. So today we're going to be looking at kind of the process for this drone cover. So we're going to walk through the different steps. So let's take a look at this. So we're going to have part preparation, right? So we're going to get something in from our customer. It may be an NX, but it's probably some piece that needs to be translated. So being able to bring in multicad into NX, so all the standard translator, IGES, STEP, DXF, DWG, JT, Parasolid, as well as being able to open up native data from other CAD systems. Then having the ability to modify that, right? So we're going to bring this in and we're going to utilize synchronous technology inside of NX to really go in and quickly update, be able to make changes without having that history, without having to have some third-party translator bring it into an NX file so we can have some kind of history. We're going to be able to take that data and really focus on making changes that we may need to update to make the manufacturing possible. But really just streamlining that whole process and being able to work with the supplied data. Next, we're going to take a look at part validation, right? So we've got a part in, we've gone through it, got it translated in, now we have it inside of NX, and we want to make sure that, we're taking a look at seeing if there's any issues. So we want to take a look with our checkmate tools and our HD tools to really understand if there's any issues. Maybe there's some small radiuses in there, maybe it's surface data and there's some little triangles in there that we need to clean, or maybe there's just some missing surface data that we need to be able to go in and clean up. Then we're going to look at, simulating the plastic process, as well as building in some parameters to be able to reuse around the parametric tool set, so that way it'll help us drive more accurate costing when we're looking at this, so we can look at how much plastic we're going to be using, get a better understanding of the tooling that we're going to need. So next we're going to take a look here at kind of the design process, taking a look at a few things here. So I'm going to go ahead and start this.
A tool designer may start with a component model that has been designed in NX CAD or as a neutral file format such as IGES, STEP, or Parasolid from his customers and OEMs. In this example, we have the component model in STEP file format. NX provides powerful translators that can import almost all types of neutral files data inside NX. Once the component is imported inside NX, next, the tool designers struggle with the bigger concern. Can this part be successfully molded? Their primary concern is whether or not this part model is properly drafted. With NX, designers can easily check the draft of a part, even if they know next to nothing about mold design. And if needed, they can use advanced features in NX to quickly correct the design for proper moldability. In this case, draft analysis showed areas with insufficient draft. Therefore, we edit the geometry to increase the draft and then rerun the draft analysis to verify. NX Mold Wizard's molded part validation tools analyzes the part and automatically provide the designer with information about draft angles, undercut areas, sharp corners, etc. On top of that, it will provide the designer with an easy visual check of core and cavity side that don't require any special analysis or knowledge of mold design. Apart from molded part validation, tool designers can also do material flow analysis. NX EasyFill Analysis Tool is an integrated mold flow simulation tool for designers to analyze plastic part design for moldability during the early stage of the product development process within the NX environment. By catching errors early, tool designers can avoid the time-wasting back and forth that occurs when the tooling department or supplier discovers that a part can't be molded as designed. A tool designer may start with a component model that has been designed in NXCAD or as a neutral file format such as IGES, STEP, or Parasolid from his customers and OEMs. In this example, we have the component model in STEP file format. NX provides powerful translators that can import almost all types of neutral files.
Sorry, I clicked and repeated it. So taking a look at, the challenges we have, we want to make sure that we have consistent design process. So we want repeatability. We want to be able to know that we're bringing this in. We want to quickly move from 2D to 3D. We want to make sure that we have a structured workflow. Staffing right now is a concern, right? So we want to be able to have a process that we can bring folks in. That's again repeatable. It's structured. So we want to be able to use as much standard parts as we can. We want to be able to reuse that knowledge that we have and be able to quickly get in and generate tools, be able to produce tooling drawings as well as downstream applications. So when we hand it off to our manufacturing side, they have tools there for working on it. So here we're going to take a look at patching some holes and creating some parting lines so that way we have the ability to create our cavities and cores.
Once the part has been validated by the tool designer, the next step is to create the mold tool design. To start, you need to create an assembly structure for your new mold design. Using conventional CAD systems can be tedious and time-consuming. By using a single command in the NX Mold Wizard, the system will automatically clone an empty assembly structure for you. Project initialization is a command in the NX Mold Wizard that allows you to create an assembly structure that can be useful for organizing and naming the components within the mold's assembly. Project initialization can also be used to specify the material of parts and helps automate shrinkage. Next, you need to specify the other details of the mold design, such as draw direction, family mold versus mold layout, etc. You also need to specify the workpiece. The NX Mold Wizard can automatically detect the correct size of the workpiece, but you can always change it manually per your design needs. To split the workpiece into the core and cavity, it is necessary for you to patch all of the openings. Using the NX Mold Wizard, you will start by accessing the Parting Manager, which is a powerful tool that will guide you through the complete core cavity splitting process. First, using the Molded Part Validation tool, you will specify all of the faces of the model, either to the core or cavity sides of the mold. Again, this process is completely automated. The next step is to start patching the openings. You can use the automated patching tools. For complicated freeform areas, use the advanced patching tools in the NX Mold Wizard, such as Trim Region Patch, Solid Patch, and Surface Patch. Unlike conventional CAD commands, these advanced patching commands can speed up your work by up to 50%. Once you have completed patching all of the openings in the mold part model, now you can generate the parting lines and parting surfaces. The NX Mold Wizard has advanced automated tools for creating parting lines and surfaces. Based on the draw direction and different regions defined, the NX Mold Wizard will automatically create the optimal parting lines. These parting lines can be easily modified if needed. The NX Mold Wizard will guide you through the creation of parting surfaces. Along the way, it will recommend surface types based on geometric conditions. Once you have finished designing the regions and parting surfaces, you are ready to split the core and cavity. With a single click in the NX Mold Wizard, the core cavity extraction can be executed automatically.
All right, so next we're going to take a look at running through the rest of building up a base, changing parameters, and then using standard components inside your mold design.
Once the core cavity is extracted, most tooling companies create mold base information in a 2D structure. This 2D information is later shared with the shop floor for production. Usually, tooling companies do this because designers creating 3D mold base structures is a very tedious and time-consuming task. Mold Base in the NX Mold Wizard provides you with the widest range of compatibility options and is based on major industry standards such as HASCO, DME, and FUTA-BA. Automatically placed components in the mold assembly is a huge time saver and aids in a more efficient workflow. The standard part libraries available in the NX Mold Wizard provide a wide selection of commonly used components that you can install and adjust, such as bushings, ejector pins, or sliders and lifters. You can also customize your libraries to match your company's design standards and expand the library to include any component or assembly.
All right, so now we saw the process, saw standard parts being used. You'll be able to go in and select your ejector pins, put in slides, be able to reuse as much as possible, be able to download from custom libraries as well as build up and create your own libraries. So now let's talk about the challenges of producing a high quality, low cost tool. Right, so there's two parts to this. First, the validation solution, making sure that we have, we're not creating errors or we find any errors so we can rework them earlier in the process before we get to the physical tryouts, right? We've already done the simulation of the flow. We can look at also using mold flow from Moldex 3D as well as DMF Pro for looking at design for manufacturability in our tools. So we can take this and really do great validation and simulation of our molds prior to creating the molds. And then on the manufacturing side, that's going to be our next challenge. So taking what we've designed and passing it off to our CAM side, to our CMM side for inspection, making sure that we have good tools. So bringing this into NX CAM, being able to keep everything in a common platform. So we design the tool hopefully, or we design the product hopefully in NX, we design the mold inside of NX Mold Wizard, and then we take that and push that down to NX CAM to create our tool pass. And then to even round it out, Siemens has a CNC controller for our machines out on the shop floor. So building in that consistency, bringing down our design time, bringing down our manufacturing side, and keeping it in a single platform, is where Siemens really focuses on completing the whole process. So now taking a look at adapting the right technology, validating our design for quality parts, and digitalizing that whole process so we're able to take that, design it, simulate it, and manufacture it all within the Siemens platform. So now I wanted to touch base real quick on what came out in the latest release. So some of the new tools that came out in the 1980 release in June of NX. So we talked about this a little bit in the beginning, this whole Mold Connect. So what this does is this allows us to have a cloud-based solution to be able to bring everybody in on the same page. So we can have our customers, we can have our manufacturing facility, our quality side, regardless of where they're at, whether they're in-house or we're working with a partner, and then you working with your customer. We're going to be able to keep everybody on the same page. They're going to have the ability to communicate and transfer data. So maybe I'm designing the mold and I need to go back to the OEM and say, hey, I'm having some issues, or I've noticed an error when we go to simulate the flow on this. can you address this, and we can collaborate back and forth. UI improvement, right? So being able to have consistent user interface across the board. NX Mold Wizard really focuses on moving from left to right in the process. So I'm going to initialize my product or project, and then keep moving across as I'm going through my design. And then just across the board on NX, being able to have consistent UI information. So if I'm looking for a button here, it's going to act and perform the same way in my modeling, in my mold, and then in my manufacturing. If there's something like a synchronous tool that I wanted to have, they're going to be the exact same tool, exact same icon, and function exactly the same with the same options. Enhanced tools, so I can go in and select my body, I can select my workpiece, and then be able to extract that in a new window when I go and create my cavity and core, just so I can go in and visualize that. Ejector pins, so there's new post-processing to handle this, so new options for how to save it as unique parts, right? Because I'm gonna buy or order an ejector pin off the shelf, and then as it gets cut, I'm going to have it inside of NX, and I can apply custom parameters for saving it off as a unique part, because every pin is going to be different. New pocketing information, so the ability to edit the pocket and position features, enhanced performance for the screw families. Cooling channel improvements, so being able to get in and design in the context, being able to extract fittings from our standard parts, and then the ability to make changes to the circuits, plus just being able to process this a lot quicker, being able to get in and change information, add O-rings into the channels. It just produces a better, more efficient cooling. And then on the vent design, again, being able to allow the user to specify lengths, edit the border lines for the different types, and allow the user to switch direction for an individual loop, right? So you decide maybe you want it a little bit different. You have that flexibility. BOM changes, so this is a nice feature here. It's going to highlight anything that has changed. So you're going to be able to get a quick visual of what has changed in the BOM. I know I've had some customers ask about this, or they've had some issues, so maybe they're not using NX CAM for downstream applications, but they're relying on face colors to be able to drive like feature-based manufacturing, or have the ability to control based on colors different manufacturing processes for different CAM programs. So this gives you the ability to toggle. It gives you the ability to make sure that the outputs are going to be colors that you're going to recognize downstream. Again, I know I have a specific customer I met with. This is going to be a benefit for them. And then being able to go in and apply barcodes and QR codes, so that way you can scan it on your prints, and you can have this information in there. And then some enhancements around engraving text into your part. So these are all benefits. If you're on the newer versions, definitely check out the what's new. You can drive right down to the tooling section and see what changes have been made. You can also go on the Siemens site and look at what's new. There will be a new release coming out here in February 2007. So once that's available, we will definitely have a session of what's new. But I think we're also going to focus on doing a deeper dive into the what's new over the last couple releases of some of the key enhancements. So I'm just giving a brief overview of these. I think we're going to see kind of what the response is and maybe dive deeper into some of these with some actual demos around this. So if there's any questions, please submit them in the chat. Thank you very much. We'll give it a minute here to see if any questions come through. If we can't answer your question today, we will definitely respond back and dive into it deeper. We'll have an application engineer here reach out to you and get back on that. So it is generated in the software, and you can edit that QR code with your information in there. So definitely. And I'm going to take a note of what questions we get in, so that way we can do deeper dives into the areas of interest. Looks like we have another person typing in a question. Right, so it's not, it sounds like the question is, how are the new versions named, and are they based on year? The numbers sound like they're based by years, but they're really a build code. So NX has gone after NX 12 to a continuous release. So there's different main platforms. So like 1980 release was a major release, but you'll have 1980, 1986, and so on. I think I'm on 2000 now. It's really just a build code that they're updating these to. The concept behind it is you're able to get in and quickly update, and you're not waiting 18 months for a new release to come out to have functionality come in. So it's coming out on about a monthly basis, and we would normally know those as maintenance packs or maintenance releases where they're just doing fixes. The continuous release, if they have a tool that's ready to come out, they're pushing that tool out instead of waiting for the next major release, which for NX was on about an 18-month process. So they have like a major release, which, like I said, 1980 was the last. 2007 will be the next one. But in between, round on a month cadence, they have an update which will give you new tools and new functionality. And in between each one of those, so from 1980 to 2007, you can open files back and forth in that range, right? I can open up, on 1980, I can open up anything that was released previously. But if I have a file that was created in 1980 and I'm running, or I'm running 1980 and I have a customer that provided me a file that was saved in 2000, it's still in that range, and I'm able to open it even though I'm only on 1980 and they're on build 2000. I still have the ability to open that. Yep. Is there any other questions? And again, please feel free to reach out if you have anything more in depth that you want to look at. Oh, yeah. So, okay. Kim's going to put my contact information in there. So again, my name is Jason West, jasonw@camlogic.com, or you can call at 248-572-3535. Again, feel free to reach out and we can get you in contact with the proper application engineer and go from there. All right, everyone. Thank you for joining today. Again, if you have any questions, please feel free to reach out. And we thank you, and everyone have a great day.